This is a question on kinematics equation assignment, which I have experienced a lot of questions year to year. So therefore, I will explain it to you, and then you can solve it with the other one. A car A travels with a constant velocity of 45 meters per second east, and at the same time, car B is starting from rest, and it is traveling with an acceleration of 5.34 meters per second going west. The cars start at 361 meters apart from each other, and now we are determining the distance that car A has traveled. So the situation is something like this. This is the starting point for car A, and this is the starting point for car B. So for car A, he's moving, or the car is moving with a constant velocity of 45 meters per second going on the east direction, while car B is starting from rest. So this is initial velocity of car B is equal to 0 since it is rest, and it is accelerating with a positive acceleration because starting from rest and then it is moving at 5.34 meters per second squared going in the west direction. Now the distance between car A and car B is 361 meters, which and now they start at the same time and they will meet somewhere. So let's suppose that the point that the two cars are met is this point here. So this is the meeting point. So during the time that car A is traveling, it is traveling for a distance dA. Okay, and during the time that car B is traveling before they meet is dB. So this is the same as saying that those two cars are moving, one with a uniform motion and the other one with a non-uniform motion. So how do we know that is a uniform motion? Is because we are dealing with a constant velocity. So the distance that car A is traveling, or displacement that car A is traveling, is whatever is the velocity of car A times time that car A is traveling until they meet. And on the other hand, since for car B we have a motion that is accelerating, then the distance that displacement that car B is obtaining as it is moving with acceleration will be VIB plus AT squared. So 1/2 A2T squared. Now, since the initial is equal to 0, then we can say that the displacement that car B is obtaining is 1/2 A of car B times T of car B. However, the key here is that they start at the same point and they meet at the same point, okay? Because when you start at a certain point and then you are heading toward each other, then you will meet at the same point, meaning that the time that A is traveling is the same as the time that B is traveling. So this kind of reduce our equation a bit more, because now we have that the distance or displacement that car A is moving is the velocity of car A times T, which is the time that each of them travels, and the distance that car B is moving will be 1/2 the acceleration of car B times time. Now, another key point on this question is that the sum of the two distances, distance that car A is traveling added to the distance that car B is traveling, is the total distance between car A and car B initially. So now we can draw the third, or having those two equations, now we can say that how can we relate those two? So dA plus dB is equal to 361, which in our case is the distance between A and B. So then we will have 45 meters per second times t plus 1/2 times acceleration of car B was 5.34 times t squared is equal to 361. Or if we divide now 5.34 by 2, then we will have 2.67 t squared plus 45t is equal to 361. You can solve this, as we said, using quadratic equation or using y1, y2 in your graphing calculator and find what is the point of intersection. The steps are on the previous documents, which you can refer to. For now, what we will do is we will solve it using quadratic equation. So in quadratic equation, the formula for quadratic equation is negative b plus minus the square root of b squared minus 4ac, the whole thing divided by a, 2a, and ABC is the same as coefficient in front of the variable squared. B is the coefficient in front of the variable to the power of 2, and C is the free coefficient. So we have to manipulate this equation a bit. This will be 2.67 t squared plus 45t minus 361. So this is telling us that A is 2.67, B is 45, and C is negative 361. So time will be negative B, which is 45, so negative 45, plus minus the square root of 45 squared minus 4 times 2.67 times negative 361. And the whole thing is divided by 2 times 2.67. And if you do the calculations, you should have two values of time. One that is dealing with the negative root and the other one that is dealing with the positive root. And those values are, for the positive will be t equals to 5.93 seconds, and for the negative one will be negative 22.79 seconds. However, we cannot have a negative time, so this is a non-permissible value. Therefore, the time that that each of those cars have to travel is equal to 5.93 seconds. However, the question doesn't end here, because it is, excuse me, it is asking you what is the distance that car A is traveling, I believe. So car A is traveling. Therefore, what you will do is you will find that car A that has a constant velocity of 45 times 5.93 seconds. This will be the distance that car A is traveling. So 5.93 times 45 in our case will be 266.85 meters. And the check that you can do, this will be the answer, to the question. However, the confirmation that you can do to make sure that the question is right, it's to calculate what is the distance that B is traveling. So you will go 3 point, oh no, it's not 3, it's 5.34, sorry. It is 5.34 times 5.93 squared, and check if the sum of the two is 361. So 0.5 times 0.34 times 5.93 squared. And the distance that B is traveling is 93.89 meters. So when you add the two together, you should have 361. This is how you check that your answer is actually correct. I hope that this makes sense. I will post this on Google Classroom.